You can do a horizontal shift to the left, a horizontal shift to the right, vertical shift up, vertical shift down. But, Mr. Park, I know for sure you've seen this. And June, I know you've seen it. She was asking this, which I thought was excellent. She says, is it possible to revolve this? Not reflected. I said, revolve? What are you talking about? And she said, revolve it. You like the professor, take it and spin it. Spin that parabola around. And she mentioned maybe the y-axis. Guys, we visualize this thing being spun around the y-axis. It may form something that looks like this. That's calculus. That's pure calculus. And guess what they'll be eventually asking you probably to come up with? Mr. Park, June, you guys can confirm this. What might they ask you to do after that? Well, this thing's going to form a solid. If you revolve that parabola around the y-axis and spin it around, it's going to form a solid. Something like the cone, where I pouring water into the cone, on the problem we did here in class. So they're going to ask you maybe to come up with the volume. How much water will this thing hold? June, can you guys confirm this? You will see this, right? And she brought that to my attention, and I said, wow. She said, somewhere in her physics background, she's a professor. I was thinking, could you revolve this thing rather than reflect it? And you could. And in Math 7, you will. Then they'll ask you to come up with the volume. We'll give you different methods to do it. Are you guys still using the disk method and shell method to find the volume? Okay. So I thought I'd point that out. Another, where's June? June asked, good question. She asked today, she says, Professor, if I see, when you describe the end behavior, and I see my graph that I'm trying to graph should behave the same way as x squared behaves. She says, we did some of those, I know how x squared behaves, that parabola. Back here it is, behaving like this on the ends, end behavior. She says, if it's an x to the fourth. Beautiful question. Suppose it's an x to the fourth, and I'm trying to make my graph on the ends behave just like x to the fourth, or something about x to the fourth. And she said, Professor, you said you go ahead and accept that x squared parabola as an x to the fourth, or x to the sixth, or x to the eighth, right? June? Beautiful. She says, Professor, isn't there a difference in the graph of x squared and x to the fourth? Is there a difference? If you really want to get specific here, is there a difference between the graph of x squared and x to the fourth? We know what x squared looks like for sure. Now, June described, if you don't mind, I don't want to put you on the spot. She says, Professor, is there a difference? Tell me what you told me, or tell the class what you told me. No, the difference. Yeah, right here at the what, vertex. She says, Professor, if it's an x to the fourth, it starts flattening out. You said, flatten out? What do you mean? Look at this, guys. If I take just a few points, do this. I'm so glad she brought this up. Let's compare. Let's try the x column here, some numbers close to 0. At that vertex, close to 0, some numbers close to 0. Like, my goodness, I'm going to throw some numbers in here. I'd like to put them in order if I could. Let's try maybe 1/2, 1/3, maybe 1/8. Let's see, so be reasonable here. If I square those, are you okay? 1/4, 1/9, 1/64. So that means if I should go to the parabola with these values in this table, you'd move out 1/2 up 1/4. This one you move out 1/3 up 1/9. Move out 1/8, you go up 1/64. So guys, is that 1/64 pretty close to the x-axis? In fact, are all these values, when you plot them, are they close to the x-axis, barely above the x-axis? Is 1/4 barely above? Well, of course it is. 1/9 is barely above. Now if I do x to the fourth, with these same x values. Now I've got something like this. 1 over what? 16. Is this number going to be closer to the x-axis than my 1/4 from that quadratic? Is 1/16 up just barely above the x-axis? Is it closer to the x-axis than 1/4 is? And you compare the others, and I think that's what she has in mind there. She says the professor's flattening out. If you try x to the 4th. June, that's mathematics. I'm happy though. She's a professor, but I see x to the 4th, gotta just deal with it like x squared out the ends there. Or make it, if you have to graph it, maybe flatten it out here at the vertex. I told her, please, if I see the shape, and it's something like I want to see just for the shape, I'm good. I'm good. I thought I'd point that out. It does flatten out at that origin vertex. Woo! Okay, guys, here's what my plan is today. Did I give you guys a handout? Maybe I'll give you out so many handouts. Are these handouts helping, by the way? Boy, they're keeping me busy. They are keeping me busy. I gotta stop every morning and pick up the copies. I'm busy here. Was it on polynomial functions?
Yeah.
I hope. That's what we were dealing with, I think yesterday. That p of x equals, so we started looking at some things about it. A p of x, a polynomial function. Guys, if I'm not mistaken, I don't want to mess up here. I got more here. Was there a page something like this? And Mr. Park, I checked what you sent to them. I think you sent the answers out to this. Right, guys? I think we're looking at this. I know you need a copy here. Did you contact me yesterday? Yeah, if you have to, you gotta contact me.
I was out to this.
I know it. You have to email me, let me know. I think you dropped class. Okay. Now let's do this. Absolute blessed to have students thinking like that. My goodness, thinking things we're doing here and thinking ahead. That's back to this on the polynomial functions. Mr. Park, I noticed the answers you sent out, and I'm going to take a look at just a few of these on that handout and move on. By the way, guys, is this the one that had the graph drawn for you at the very bottom? And then they ask you, can you look at the graph and name the function that the graph came from? Okay, now you guys please help me, everyone has a copy. Let's go jump down to that graph first. Let me get that out of the way here. Can anyone tell me, look at this, guys. I'm caught zeros, you love that word, x-intercept. Anyone tell me what the x-intercepts were, and when you tell me what the x-intercepts or zeros are, can you tell me, let's say, multiplicities? Can you tell me based on that graph, maybe? And there's a touch or cross, and we'll get that touch out of the way. Who would like to volunteer to tell me the zeros? And some information. Bill, go for it.
-2 on the graph on the bottom, right?
Yeah.
-2, 0, 2, and 3.
Okay, now -2 is -2, based on what you see on the graph, would you expect this to cross, touch? Did it cross or touch? It touched. Okay. And what was another?
0.
0, what was it doing there?
Cross.
And another?
2.
2, okay. And?
Cross.
Cross again. And was there anything else?
3.
Oh, 3, okay. And?
It touched.
Okay. Now, my directions. I remember doing this graph for you guys. Did I have in the directions there just write the function that this graph represents or something to that effect? Okay? Now you say, Professor, I follow what you're doing in class. Phil gave me this. He says that -2 it touches. So I would say, wait, now I know what that means. I mean, it came from the factor x plus 2. That's where the -2 came from. And since it touched, that might indicate to me what I can place on the outside as an exponent. What did we decide yesterday to place on the outside?
Or like power to the 2.
It could be a 2, as long as it's even. And usually I ask for the lowest degree, so it could be a 2, 4, 6, 8, it's even one touch. So guys, when you use the lowest, let's try 2. This one he gave me 0, which is interesting, that means just X. We can make it 0. And he tells me on that graph it crosses, and that should indicate what? An odd. And I'm going to use the lowest. Let's use 3. Oh, you know what? I can go lower than that. What? 1. The odd. So even lower. Next he says, Professor crosses again at 2. So this was X subtract 2 factor. And I could use one of your guys at 1 again. If it crosses. And then touches at 3, X subtract 3, and he tells me it touches, and we use 2 again. Are we okay, guys, with the even odd, they cross touch? Now, if I'm not careful on the exam, not the exam, but next week, I give you a quiz or an exam on this chapter 3. If I'm not careful, I'll have students say, Professor, could I have placed a 4 here rather than a 2, because 4 is also even. And would you give me credit? I would have to. Except I'm going to be very careful in my directions. I'll probably ask you to express it in the lowest degree. So the lowest that you can express the odd even. Yeah, I could have it. If a student says, Professor, here maybe 4, maybe here 3, maybe here, can I mix it up a little bit? I'll just say please put it in the lowest. Yes?
Wouldn't it also help to like find out how many turning points there are?
Yeah, exactly. Hang on, we'll find out here shortly. Beautiful, absolutely. Now, Philip, we've got that so far, right? Okay. Now, Andrew, tell me how many turning points, that's the max and min, altogether do you see on that graph?
I see 5.
5. Okay, let me add these up. Mine right now are 2, plus 1 is 3, plus 1 is 4, and 6. So I have 6 altogether for my exponents. And you said subtract 1. The rule is subtract 1 from that and 5. So at most you can have 5 turning points. He says, Professor, we lucked out here, we get all 5.
Yeah.
You?
Because if you did 4, then.
There you go, there you go. Beautiful. All right, yes. Well, I'd like this class to be bragging on you guys. Jeez. Some of my colleagues were telling me that students just sit there and watch and don't say a thing. Oh, crazy. Yeah. So the number of turning points will work out. So I'm going to do it like this. Thank you, Andrew. Now, guys, if I write this out at this point, Philip, we'll come back to you. I've got P of X is equal to, based on what we have here, do this, X plus 2 squared. I've got an X. I think it'd look better with the X out front. X subtract 2, X subtract 3 squared based on what he gave me. You guys agree? Trying to write the functions that graph represents. Now, I gotta be careful. You gotta be careful. All right, is there usually a coefficient out front? Is there usually a number stuck out front here? Sometimes. Maybe a 2, 4, 5, some type of coefficient. And in fact, on the quadratic, you saw leading coefficient outline. Is there a leading coefficient here? Let me show another student here. Philip, let me go back to you since you have it. Did I give any more points, or did I label any other points besides the zeros, the x-intercept? Did I label the y-intercept? Where's the y-intercept?
0, 0.
Oh, that's not interesting. Okay, 0, 0. Did I label anything else? Oh, I did.
Yeah.
What was the other point?
1 minus 4.
1 and negative 4?
Yes.
Beautiful. Now, if I had not given you that additional point, I would accept for your answer, you would be finished. This is the equation, the function I'm looking for. But now I'm being more specific. I said, hold on. I give you an additional point to work with. What do you think I'm asking you now to do with that point labeled 1, negative 4, to do here? Why did you leave that point there? Because my students are saying, Professor, that point's on there. Why'd you place that point on there? What do you think I'm gonna do? Go.
Find the slope.
Nope, nope, something easier than that. Andrew?
To distinguish as like, when?
Maybe that, something a little easier. Yes,
Input the x and y values and solve for a.
look at this. -4 right here. Perfectly set, p of x or y is -4. Now out front, that means I may have a number coming in here that I don't see right now. We'll call it a. And in place of those x's, let's put a 1. I think 1 was given to me as all the, or the x's here, or all the ones. Put it in. You guys agree? That's why I gave you that point to work with. You're able to now plug in those numbers. That's going to end up with -4. Here's a representing my leading coefficient. And I think I need all this arithmetic done. And I see if you agree with me, guys, I see a 1 here. I see a 9 here, I think. I see a -1 here. And it looks like a 9 again here. Let's sit back and notice. I'm 9, that's a 4. You guys agree? Are those the values of those when I go through? That product altogether, I think, is, help me out, is that -36? Is it -36?
Yes.
Now you can solve for A. Divide both sides by -36. -36. Let's cancel. Well, we end up with a positive. Looks like positive 1/9 if I have no mistake in the math. Is that true? Now I know, to be more specific, that the red function now can be written like this. Erase this. You can now add to it, and of course put it in red. Professor, there's a 1/9 out here. And now I'll accept this as the function that graph on your handout represents. Mr. Park, did you actually go through and show them the 1/9? I think you did. I think I looked at your work. I'm checking your work when you turn it into.
Okay.
I'm checking your work too. Okay. Guys, you understand what's going on here? So I thought I'd better point that out first. Now that said, I know there's some other items on that. Let me do this before I give you another handout here. Part 2. I think, let me check here real quick. Got the graph out of the way. Oh my goodness, we're finished. Did we do some of this yesterday? I'm sure we did. Some of this graph. Yeah, it's done. Now, what I want to do, and thought about you, pass this out. We're gonna work it together. This is what I gave one class, the previous class, a quiz. This is their quiz on the polynomial functions that we're talking about. And I had a real cute little saying up here at the top, and darn it, when I picked my copies up this morning, that little saying up there stopped. Something about math. Yeah, I forgot what it said, something about, it was cute, like a little cartoon. It had math involved. I picked it up and I don't see it, I just see a little desk at the top. I don't see the saying there, I'll find it.